In this video, you will learn how to pass an overstressed column in Etabs. There are different kinds of overstressing, so I'll be discussing a few tips. If the lateral shear force exceeds the column strength, hence make the column support pin, that means the column will distribute the shear force to the other columns as they will become axial force in the space frames. If the main steel exceeds column limit, so try applying end releases to the beam. Practically, it will design beam with enough steel so that it is able to resist the applied moments and transfer shear force to column in form of axial forces. If columns are failing in irregular pattern, try changing the overrides for the column. If column is failing in steel limits, i.e. main steel is exceeding, try increasing the cross section, or fails in shear, try increasing the cross section based on architecture restriction. Also, you need to check the drifts in order to select a particular cross section of the column. Now we will be applying these checks and tips to pass the column. This is the same structure we used in the previous video to pass the beams in overstressing. The link to previous video is given in description. So first of all, I'll be showing the lateral load applied to the structure, also the loads applied to the shell. It is 40 psf and 36 psf. We will be seeing the cross-sectional properties. The beams are defined as follows, while the columns are defined as shown. So the load cases are set as default concrete load cases, and also the combinations are default, which we will be using for design of the concrete frame elements. The design will be following the procedure of ACI code. Now we will be assigning the diaphragm to the structure. The diaphragm type will be rigid as it is a concrete slab. Now we will be selecting column and assigning the property for gross moment of inertia according to ACI code chapter 10. Similarly for the beam, for crack moment of inertia and incorporation, since it is a concrete structure, we will be using 0.35 of the cross section. Save the structure, renaming it as columns as the same structure was used for the beams. First we will be running the model and then designing the concrete frame. Starting to run the model. Since P delta was defined, so it is reanalyzing for updated loads. Now designing the concrete frame elements such as beams and columns. Since we are not interested whether the beam passes or not, our concern in this video is to pass the columns only. Let's first hide the beams so that it does not create further confusion, as we have already passed the beams in the previous video for the same structure. Now you see few of the columns are appearing to be red while others are passing. So it's showing overstress number 2. That means the column is exceeding the longitudinal steel as compared to the cross-sectional constraints. Now we will try to make the beams pin support, or just apply the end releases to the beam so that the beam will resist the moments itself and transfer only axial forces to the columns. So assigning the end releases so that the beam will be designed with enough positive steel that it won't transfer the negative moment to the column. Only the axial forces will be transferred. Let's see whether it works with our case or not. Now let's design the concrete elements. So you see there is an improvement that the columns that were failing previously are now passed, while few others appear to be failing. So we have to apply a different remedy for them. The last option to be considered is increasing the cross section. Before that, we will apply different techniques as discussed in the start of the video. So it's already selected so intermediate. Now we'll try to increase the cross section and see if the cross section works for the particular column. The column has now passed at a size of minimum 8 inch by 24 inch. Since the cross section has to be uniform as per architectural requirements for this particular case, let's make them 8 by 24. Now run the analysis again. Note that since we are assigned pin or end releases to the beam shall be designed in the similar manner, as the forces transfer should remain same. Now it is designing the elements. So you see this column is particularly failing. So we'll apply another technique. Let's try, it's already so intermediate. So we may increase its cross section or assign the base of the column as a fixed support. Let's see whether it works or not. First checking whether the increase in cross section will work for one dimension. So now the column has passed the increase in dimension for that particular. So we'll be assigning the similar cross section to the symmetric members or the mirror members to keep the structure similar. Assign the cross section which seems to be passing. So running the analysis again after assigning the particular cross section on which the columns appear to be passing. Now run the concrete frame design. Now most of the columns are passed. Almost all of them has passed for this particular story. It is important that the range of the steel shall be practically implementable on the site. Typically in practice we don't take steel more than 4% in column. So you see most of the columns on the story below are failing. Now our job would be to pass the columns of this story as well. Now we will be applying end releases to these beams. In the similar manner we applied the end releases to the beams of the story above. For the major moment. Now rerunning the analysis and then the frame design. Hopefully it will pass most of the columns. I see most of the columns have passed, but it is also important that the increased cross section on the story above shall not be more than the cross section on the story below. Practically we keep the cross section same or higher on the story below. So now most of the columns on this story are failing. Let's turn on joint objects and see the base of the columns as pin or fixed in some cases. Now we have to assign the end releases to the beams of this level as well. As most of the columns of this floor are failing. Now let's give it a try after running the analysis whether this story's column pass. After applying the same technique we applied on the stories above. Let's turn on the visibility of the columns. So you see not much positive change have shown. Most of the columns are still failing and the main steel is exceeding the cross section limit as it is written O as number 2. That means main steel is exceeding the cross sectional limits. Let's increase the cross section as it also appears to be practically more valid since the cross section of the upper stories is, I suppose, same. It must not be less than the cross section of the stories above. Now let's design the elements. You know that design is an iterative process. You have to do revisions if that particular cross section is not passing. It's not that in the first run your whole structure will pass all the checks. You have to keep revising. So you see the columns are passing except a few. Let's increase their cross section and design. Now it's passed. Similarly, we'll do it for the others. From the design overrides, applying the cross section of 12 by 18, and it also passes. So you see that's the way we pass the columns. Still this one is not passed, so we'll be increasing the cross section. This one is not passing. It's strange that the other columns are passed. It must be due to the effects of earthquake. Similarly, we have to assign a uniform cross section to the other columns, as 12 by 21 is working here. Due to sway of the structure, probably, usually earthquake combination governs. What is the bottommost story? We'll be applying the same remedy. In the beginning, we'll be assigning the end releases. Usually we don't apply end releases in a bulk, as it increases the main steel of the beam and reducing the top compression steel or the steel on the supports. And yes, it is practically valid to apply the end releases to the beam, as it increases the main bottom steel in the beam. So that the beam will be designed in order to absorb all its moment, transferring to its main steel. But the detailing of joints shall be using the particular type of framing, IMRF or SMRF. So you see still the columns are failing due to cross section. Let's check what's the issue. Reinforcing exceeds the maximum allowed. That means the cross section is small for that particular kind of loading. Hence we have to increase the cross section. There can be other ways in order to reduce the forces on the cross section, but since we have increased the cross section in the stories above, so we have to increase the cross section of the stories below, which is technically sound. Let's try 12 by 21, running the analysis. Hopefully this will work. You can also increase the cross section 1 inch or 2 inch at a time, but for demonstration purposes I am applying the particular set of cross sections. It is important that after the stress check and the main steel check, you also check the drift limit torsion irregularity in the building, which I have shared in my channel in the Etabs tutorial playlist, whose link you can also find in the description of the video for complete Etabs course. So you see most of the columns have passed, almost all of the columns have passed. If you want to see how the overstressing of the beam is controlled, please check the video whose link is given in the description. It is also important to check whether the reinforcing percentage is not high enough so that it's practically not placeable in the column. You see the percentage here is 7, which is very high. Practically we want to be able to apply that particular percentage of steel. You have to see the percentage of steel for one story at a time. For column design tutorials, you can visit the channel. I have uploaded column design tutorials for intermediate moment resisting system, sway special and circular columns. And also the check of existing columns using section designer is also posted. For complete Etabs tutorial, see the link in description. So you see the shear force here is shown, and the 5Vs that will be carried by shear steel is 0. So that is how we pass the column who are overstressed. Also check importantly the drift and other serviceability checks. Thank you for watching.